Story 1. Granite that behaves like Metal Giza Plateau. Egypt. The object was not a monument. It was debris. In the late 19th century, British engineers surveying the Giza Plateau collected granite core samples discarded near unfinished shafts. They were not decorative. They were industrial byproducts, cylindrical drill cores cut from solid Aswan granite, one of the hardest stones available to the ancient world. The actor was unknown. The date was disputed. But the material was unmistakable. Then the measurements began. Granite is not supposed to yield cleanly. Copper tools deform. Sand abrades slowly. Yet these cores showed spiral striations consistent with high-speed rotary drilling under constant pressure. Microscopic analysis revealed feed rates exceeding what modern reconstructions allow, by an order of magnitude. The grooves were uniform, parallel, predictable. One engineer calculated that the drill advanced nearly 500 times faster than experimental copper drills could manage. The scans disagreed. The stone did not lie. No tool marks. Too fast. Too precise. When these findings were circulated internally, the response was not replication. It was containment. Access to original cores was restricted to select institutions. Requests for destructive testing were denied. Subsequent papers were labeled speculative and quietly archived. By the mid-20th century, the samples were removed from public display entirely, cited as non-contextual. No excavation team could say where they went. One researcher pushed back. A materials engineer attempting to model the drill geometry submitted proposal for electron microscopy. Funding was approved, then rescinded. His university advised him to shift focus. He did. He missed his daughter's graduation while on reassignment abroad, studying unrelated alloys. The granite cores were never mentioned again in his publications. The official explanation remained simple: experimental error, misinterpretation, enthusiasm outpacing evidence. But the numbers persist. The striation pitch, the core taper, the absence of chatter. Modern machinists recognize the signature instantly. It resembles a hollow drill with hardened cutting edges and control feed, technology requiring precision bearings and power transmission, none of which should exist in Old Kingdom Egypt. Then there is the tolerance. Independent measurements taken before restrictions tightened recorded dimensional variance within 0.02 millimeters across multiple cores. That level of consistency implies repeatability, not accident, a process, a system, and systems leave infrastructure unless they are dismantled. The question is not how the pyramids were built. It is why the debris tells a more advanced story than the monuments themselves, and why that debris keeps disappearing. Measured tolerance confirmed: 0.02 millimeters. Story 2. The Electric Cells, Baghdad, Iraq in 1936. During routine excavations near Kajut Rabu outside Baghdad, workers uncovered a small ceramic jar. It was unremarkable at first glance. 13 centimeters tall. Bitumen-sealed mouth. Inside, a rolled copper cylinder and an iron rod, isolated from direct contact. The artifact was logged, boxed, and sent to the Iraq Museum as a curiosity. No inscription. No ceremonial markings. Just components. Then someone assembled it. When filled with acidic electrolyte, vinegar, wine, or citrus, the device produced a measurable electrical potential, around 1 volt, stable, repeatable, not enough to power a city, enough to plate metal, enough to stimulate nerve tissue, enough to matter. A battery. 2,000 years early. Copper cylinder. Iron core. Current detected. The evidence was recorded by museum staff and later replicated by independent engineers using period-appropriate materials. Voltage readings were logged. Residue analysis found copper-silver ion traces consistent with electrochemical reactions, not storage contamination. One internal memo, later leaked, referenced copper-silver electrolyte notes. 1936. Suggesting experimentation beyond a single artifact. That memo never appeared in the public catalog. The response was swift and procedural. The jars were reclassified as ritual objects. Testing was halted. Export for laboratory verification was denied under antiquities law. Papers proposing practical use were rejected for contextual overreach. The devices were moved to storage. Access required layered approval. No photographs after 1978 show the interiors. One technician noticed something else. The bitumen sealant showed repeated heating cycles. Nota single pour. Maintenance. Use. He reported this in a draft report. It was removed in revision. Months later, he was reassigned to inventory work. He never returned to field research. He died before his findings were revisited. His notebooks remain uncatalogued. The official dismissal is familiar. Coincidence. A container. A scroll holder. A religious charm misread by modern bias. But that explanation fails to account for standardization. Multiple jars. Similar dimensions. Identical component spacing. Uniform voltage output within narrow tolerances. Rituals do not require insulation, nor do they require optimization. Experimental reconstructions show that substituting silver for iron increased efficiency. Which raises a forbidden question. Was the original design already optimized, and if so, by whom? The presence of silver ions in residue implies experimentation, iteration, and knowledge of outcome. Not accident. Not symbolism. The deeper anomaly is not electricity. It is intent. Someone designed a closed system to control chemical energy. Someone tested it. Someone repeated it. And someone, later, decided that story was unacceptable. Because electricity implies infrastructure. And infrastructure implies a lost branch of applied science. The file trail ends abruptly. After 1936, references collapse into footnotes. The jars remain officially denied as technology. The memo remains missing, but the voltage still registers. Output logged repeatedly. 1 volts. Multiple units. Story 3. Sound that shaped stone Pumapunku, Bolivia. High on the Altiplano, near the ruins of Tiwanaku, massive andesite blocks lie scattered as if dropped. They are not rough. They are engineered. Each stone carries recessed channels, right angles, and interlocking profiles cut with a precision that resists explanation. No mortar. No filler. Just geometry. Pumapunku was not assembled. It was fitted. The discovery phase never ended because the question never stabilized. How were these shapes made? Andesite is harder than granite. It fractures unpredictably. Bronze tools shatter. Stone hammers bruise. Yet at Pumapunku, the cuts are sharp, internal corners are square, and channel depths repeat across blocks separated by meters and centuries. Surveyors documented symmetry within fractions of a millimeter. The stones behave as if they were milled. Too clean, too uniform, too repeatable. In the 1970s, a multidisciplinary team attempted to map the blocks for reconstruction. Among them was an acoustic specialist invited almost as an afterthought. His contribution changed the file. He noted that the channel dimensions matched resonant frequencies capable of inducing vibration in andesite under specific harmonic loads. Laboratory tests on smaller samples showed microfracturing along nodal lines when exposed to sustained low-frequency resonance. The lab notes referenced earlier work, oddly citing copper-silver electrolyte notes. 1936 as a comparative example of controlled energy systems. The implication was careful. Not that sound melted stone, but that vibration could reduce internal shear strength, allowing precise shaping with minimal force. A method, a process, not magic. The report never circulated. Site access was curtailed shortly after. Heavy equipment permits were denied. High-resolution scans were labeled disruptive to preservation. The acoustic specialist was removed from the project, officially for budget reasons. His field recordings were seized for archival standardization. They were never returned. No raw frequency data from Pumapunku exists in public repositories today. One local guide paid the price. He assisted the team for years, helping position sensors and mark nodes. When the project ended abruptly, his income vanished. He sold his land to move his family. The stones remained. The work stopped. He never saw the final report. Skeptics argue the fits are exaggerated, that erosion sharpens edges, that modern measuring tools impose false precision. But erosion does not create right angles. It does not replicate identical channels across dozens of blocks. And it does not explain why so many stones appear half-finished, as if a process was interrupted mid-operation. There is a deeper anomaly, standardization without scale. The blocks vary in size, but the interfaces do not. That suggests a shaping method independent of mass, one that acts on material properties, not brute force. Sound qualifies. So does control vibration. No ancient text describes the technique. No tool survives. Only the result remains, locked in stone. And like the jars in Baghdad, the most interesting data vanishes at the archive door. Joint variance recorded, under 1 millimeter across multiple blocks. Story 4, the machine that predicted the sky Antikythera, Greece. In 1901, sponge divers sheltering from a storm off the Greek island of Antikythera found a shipwreck. Bronze statues, coins, amphorae, routine antiquities. Then someone noticed the fragments, corroded bronze plates fused into a rock-like mass. They were boxed, labeled, and forgotten in the National Archaeological Museum. For decades, no one knew what they were holding. When the fragments were finally examined closely, gears appeared. Not decorative. Functional. Interlocking bronze teeth cut with deliberate ratios. As X-rays improved, more emerged, dozens of gears, stacked, meshed, constrained. This was not a clock. It was a calculator. And it should not exist. Too complex. Too early. Too exact. CT scans revealed a differential gear system capable of modeling lunar motion, eclipse cycles, and planetary periods with predictive accuracy. The device encoded the Metonic cycle, the Saros cycle, and correction for the moon's irregular orbit. These are not observations. They are mathematical abstractions. Someone translated celestial mechanics into hardware 2,000 years ago. The evidence is not disputed. Tooth counts are measurable. Ratios are fixed. Inscriptions, barely legible, label functions and cycles. Engineers who reconstructed the mechanism confirmed its capability. Turn a hand crank, and the future of the sky unfolds. Eclipses predicted decades in advance. Planetary conjunctions map mechanically. Then the questions became dangerous. Because this level of gearing implies a manufacturing base that leaves no trace elsewhere. Precision cutting. Standardized teeth. Calibration. No other device like it survives. No workshop. No manual. No evolutionary trail. The machine appears fully formed, then disappears. The suppression was subtle. For years, the fragments were misdated, described as an astrolabe or a novelty. Publications minimized its implications. Early reconstructions were dismissed as speculative. Funding for further scans stalled repeatedly. It took nearly a century for consensus to admit what the scans already showed. This was advanced technology, out of place in time. One researcher paid for insisting on that point. A mechanical engineer working on gear simulations pushed for broader claims about lost Hellenistic engineering traditions. His 10-year review coincided with those publications. It failed. He left academia. He missed his son's first year of school while relocating for contract work. The mechanism remained in the museum, unchanged. Skeptics argue it was a one-off, a genius anomaly, a toy for elites. That explanation collapses under inspection. Differential gearing is not intuitive. It requires prior failures, iteration, a lineage of design. You do not invent this in isolation and then forget it completely. There is also the matter of accuracy, where patterns on the teeth indicate extended use, not ceremonial display. The machine was operated, maintained, trusted, and then lost. The Antikythera mechanism forces a choice. Either ancient engineers achieved a level of abstraction we refuse to credit, or the historical record is missing an entire chapter of applied science. One that advanced, functioned, and vanished without inheritance. Like the stones, like the cells, like the sound-shaped blocks. The sky machine does not belong where history put it. Confirmed gear count exceeds 30, including one differential assembly. Story 5, stone that was melted on purpose vitrified forts. Scotland. Across the Scottish Highlands, dozens of ancient hill forts share a disturbing feature. Their stone walls are partially melted. Granite and basalt fuse together, glassy and warped, as if exposed and sustained. Extreme heat. These are not hard stones. They're defensive walls, meters thick, running hundreds of feet along ridge lines. Vitrification was not incidental. It was structural. The discovery dates back to the 18th century, when antiquarians first documented the fused stone. At the time, the explanation was simple: accident, fire, siege. But as chemical analysis improved, that story failed to hold. Stone does not melt politely. Basalt begins to vitrify above 1,100 degrees Celsius. Granite requires sustained temperatures approaching 1,200. Open-wood fires cannot maintain that heat across large surfaces. Charcoal struggles. Even concentrated bonfires fail in experimental reconstructions. Yet at forts like Tap, Knopf, and Dunadir, stone blocks are fused through their cores, not just scorched on the surface. Too hot. Too even. Too deliberate. Laboratory analysis showed uniform glass formation and controlled cooling, suggesting prolonged heat application rather than chaotic burning. Some walls appear strengthened by the process, not weakened, which implies intent. Vitrification increases compressive strength when done correctly. That raises an uncomfortable possibility. The walls were deliberately melted to improve structural integrity. The data was documented, then sidelined. Modern surveys using thermal modeling propose focused heat sources, possibly using forced airflow or chemical accelerants. Those papers were met with resistance. Museum placards reverted to ritual burning or destruction by enemies. Funding for further field experiments dried up. One proposal to recreate vitrification at scale was rejected on safety grounds, despite control conditions. A local archaeologist challenged dismissal. She argued the fort showed signs of premeditated engineering, not collapse. Her report included heat distribution maps and comparative slag analysis. The peer review stalled. She was reassigned to administrative work. She never returned to field excavation. She missed her brother's funeral while attending a compulsory conference unrelated to her findings. The skeptic alternative must be stated. One could argue that repeated fires over decades, combined with unusual fuel loads, could gradually vitrify stone without advanced technology. It is possible, but the records say otherwise. Experimental attempts to replicate the effect with known ancient methods have failed to match the depth, uniformity, and scale observed in the forts. She never returned to field excavation. She missed her brother's funeral while attending a compulsory conference unrelated to her findings. The skeptic alternative must be stated. One could argue that repeated fires over decades, combined with unusual fuel loads, could gradually vitrify stone without advanced technology. It is possible, but the records say otherwise. Experimental attempts to replicate the effect with known ancient methods have failed to match the depth, uniformity, and scale observed in the forts. There's another anomaly rarely discussed: consistency. Vitrification appears at multiple sites separated by geography and time, yet the melt patterns are similar. That suggests shared technique. Knowledge transfer. A method taught and repeated. No ancient text describe it. No tools survive. Only the walls remain. Half glass, half stone, locked in a state that should not exist. And once vitrified, the forts were abandoned. The process was not iterated. It stopped. Why develop a technique capable of reshaping stone with heat and then never use it again? The official position remains cautious. The forts are labeled mysteries. The vitrification is acknowledged but minimized. The possibility of controlled, high-temperature engineering is quietly avoided. Because accepting it means accepting this, ancient builders understood heat, materials, and structural transformation at a level we do not account for. And that knowledge did not pass forward. It burned out. Thermal estimates exceed 1,100 degrees Celsius across multiple fortified sites. Story 6. The concrete that refuses to die in Imperial Rome and the Mediterranean. For centuries, Roman harbors have endured conditions that destroy modern concrete in decades. Waves pound them. Salt infiltrates them. Tides cycle endlessly. Yet the structures remain stronger now than when they were poured. Piers at Caesarea, breakwaters at Pozzuoli, foundations across the Mediterranean basin all share the same anomaly. The concrete heals itself. This was not supposed to happen. Roman builders mixed volcanic ash, lime, and seawater into a mass that hardened underwater. That alone defies modern expectations. But recent core samples revealed something more unsettling. Inside the concrete are mineral formations that grow over time, sealing cracks instead of expanding them. Damage does not propagate. It reverses. Too durable. Too adaptive. Too intentional. Modern microscopy identified lime clasts. Small, brittle inclusions once dismissed as poor mixing. They are anything but. When cracks form, water activates these clasts, triggering chemical reactions that precipitate calcium carbonate. The crack fills. Strength returns. The material evolves. This is not accidental chemistry. It is engineered resilience. The evidence is measurable. Fracture tests show increased compressive strength decades after formation. Seawater interaction improves bonding at the microstructural level. Engineers attempting to replicate the formula found that minor deviations, wrong ash source, incorrect burn temperature, cause failure. The recipe is precise. The process unforgiving. Then the trail goes cold. Ancient texts describe ingredients, but omit ratios. Kiln temperatures are not recorded. Quarry sources are generalized. The most critical parameters are missing. When modern teams attempted full-scale reproduction, the results varied wildly. Some samples degraded rapidly. Others partially self-healed. None matched Roman performance consistently. Access became an issue. Requests to extract additional cores from key harbor sites were denied under preservation statutes. Export permits stalled. One international research team waited 6 years for approval that never came. Their lead chemist accepted a private sector position after funding lapsed. He left academia entirely. He missed his mother's final months while negotiating contracts to keep the project alive. The concrete remained untested. The suppression here is quieter than elsewhere. No raids. No seizures. Just delay. Committees. Conservation language. The outcome is the same. Limited data. Fractured studies. No unified model. Meanwhile, modern infrastructure continues to fail. Bridges crack. Seawalls erode. Repair budgets explode. There's an official comfort story. The Romans got lucky. Unique ash. Favorable geology. An unrepeatable coincidence. That explanation avoids the implication of deliberate material science. Because if Roman engineers intentionally designed a concrete that interacts dynamically with its environment, then they understood long-term chemical systems at a level we struggle to achieve. And if that knowledge was intentional, its loss was not inevitable. The deeper anomaly is scale. This concrete was used empire-wide. It was standardized. That implies training, quality control, and institutional memory. And yet when Rome fell, the method vanished almost immediately. Medieval builders did not inherit it. Renaissance engineers did not rediscover it. The knowledge was not passed down. It was severed. Which raises a familiar question. Why do certain advanced techniques appear fully formed, spread widely, and then disappear without transition? Because once you see the pattern, it stops looking like accident. From here on, the pattern stops asking for permission. Compressive strength increases decades after initial fracture. Story 7. Stone level beyond site Sacsayhuaman, Peru. Above the city of Cusco, 3 massive stone walls zigzag across the hillside. Each block weighs tens of tons. None are uniform, and yet they fit together so tightly that a blade cannot enter the seams. This is Sacsayhuaman, often described as impressive masonry. That description is insufficient. The anomaly is not size. It is flatness. Surveyors mapping the site in the late 20th century applied laser leveling equipment to the exposed faces. The results were unexpected. Across spans exceeding 2 meters, the stone surfaces deviated by less than a millimeter, not just at the seams, across entire faces. This is not the result of careful stacking. It implies controlled planar shaping. Too flat, too continuous, too consistent. The stones are andesite and diorite, materials harder than steel tools can easily shape. Hammering produces fracture. Grinding leaves irregularity. Yet at Sacsayhuaman, the contact faces are smooth, subtly concave in places, engineered to distribute load. The geometry suggests pre-planning. Each stone appears to have been shaped in response to its neighbors before placement. That should be impossible without iterative fitting, removal, and reworking at scale. But there's a problem. The stones show no impact scarring consistent with repeated trial fits. Edges are clean. Corners are preserved. If brute force fitting was used, the surface damage would be obvious. It is not. Field notes from an early survey team recorded something else. Magnetic anomalies near several blocks. Minor, but consistent. The readings were attributed to instrument error and omitted from the final report. Raw data was never released. Subsequent requests to rescan the same blocks were denied due to conservation policy. One engineer on the team proposed an uncomfortable hypothesis that the stone faces were softened or temporarily altered during shaping, allowing precise planar formation without impact damage. He was careful not to specify a mechanism. The idea was rejected as speculative. His contract was not renewed. He left Peru within months. He never published again in archaeology. He missed his father's burial while resolving visa issues tied to project's termination. The official explanation remains endurance and skill. Thousands of workers, decades of labor, patient abrasion. That narrative fails under measurement. Abrasion cannot maintain sub-millimeter flatness across irregular surfaces repeatedly. Human fatigue introduces error. Tool, where accumulates variance. The walls do not show that variance. There's also the issue of continuity. Similar planar precision appears at other Andean sites, Ollantaytambo, Machu Picchu, suggesting a shared method, not a one-off triumph. The technique traveled. It was taught, and then it vanished. The suppression here is procedural. No one denies the walls exist. The measurements are acknowledged, but not emphasized. The laser data is buried in appendices. The word machining is avoided. The possibility of advanced stone shaping methods is treated as unserious. Yet the stones remain. They do not erode into explanation. They hold their planes through earthquakes and centuries. When modern engineers revisit the data without historical constraint, they recognize the signature immediately. This looks like controlled surface finishing, achieved today with milling heads, abrasive plates, or energy-assisted shaping, none of which should be available in pre-Columbian Peru. And still, the flatness persists. Measured deviation remains under 1 millimeter across multi-ton faces. Story 8. The iron that should have failed Delhi, India. At the center of an ancient complex in Delhi stands a 7-meter iron pillar. It is over 1,600 years old. It has endured monsoons, heat, pollution, and war. And it is not rusted. This is not exaggeration. It is metallurgy. The pillar weighs more than 6 tons and is composed of wrought iron with an unusually high phosphorus content and near-zero sulfur and manganese. That composition alone is rare. But the real anomaly lies at the surface, a thin, passive film that continuously regenerates, preventing corrosion even in aggressive environments. Modern steels require coatings to achieve this. The pillar does it unaided. No paint, no plating, no decay. Early analyses dismiss the effect as climate luck, dry air, low pollution. That explanation collapsed when corrosion tests showed the same resistance in laboratory humidity chambers. The protection is intrinsic. It is built into the metal. Metallurgists examining microstructures identified slag inclusions distributed in a way that promotes the formation of a stable iron-hydrogen phosphate hydrate layer. The film repairs itself when damaged. Scratch the pillar, and the protection returns. This is not accidental byproduct. It implies controlled smelting parameters, temperature, oxygen exposure, phosphorus retention, managed deliberately. Then the file tightened. Sampling permissions became restricted. Only surface scrapings allowed. Core drilling denied. One internal report noted similarities between the pillar's electrochemical behavior and controlled ion exchange systems, explicitly cross-referencing copper-silver electrolyte notes. 1936. The implication was cautious, but clear. Ancient metallurgists understood corrosion as an electrical process, not just a chemical one. That report never reached publication. A young material scientist involved in the study pushed for comparative testing with modern low-alloy steels. His proposal required a microcore sample. Approval was granted, then rescinded without explanation. His visa extension was delayed. He returned home abruptly. He missed his wedding while resolving funding disputes tied to project. The pillar remained untouched. The official narrative settled into comfort, exceptional craftsmanship, lost tradition, nothing more. But that explanation avoids the numbers. Phosphorus content must be precisely balanced. Too much, and iron becomes brittle. Too little, and corrosion returns. The pillar sits in a narrow optimal band across its entire length. Uniformity at that scale requires process control. There is also scale to consider. This was not a small experimental piece. It was forged, transported, and erected vertically without cracking. That demands confidence in material behavior. Trial and error would not survive 6 tons of iron. And this was not isolated. Similar corrosion-resistant iron artifacts appear across ancient India, though none as large. The method existed. It spread. It worked. Then it stopped. By the medieval period, the technique was gone. Later iron rusted normally. The knowledge did not persist. No treatise records it. No guild transmits it. The pillar stands alone, a frozen proof of concept. The same pattern repeats: advanced capability, clear evidence, restricted study. Like the cells in Baghdad, like the stones in Bolivia, like the missing notes from 1936. The iron does not corrode. The explanation does. Corrosion rate measured near zero after 16 centuries. Story 9, maps that should not exist, a Piri-Reis chart. In 1929, while cataloging documents in Istanbul's Topkapi Palace, archivists uncover fragment of a world map drawn on gazelle skin. It was signed and dated 1513. The cartographer was an Ottoman admiral named Piri-Reis. At first glance, the map seemed unremarkable: coastlines, ships, notes in the margins. Then someone noticed the south. Antarctica was there, not as ice, as land. Too accurate, too early, too complete. The coastline on the map aligns closely with Queen Maud Land, beneath today's ice sheet. When modern cartographers overlaid the chart with seismic data, the match was not symbolic. It was geometric. Latitude errors were under a single degree. Longitudinal distortions were consistent with projection, not guesswork. This was not medieval imagination. It was compiled from older source maps. Piri-Reis said so himself. In marginal notes, he claimed to have copied from ancient kings' charts, including materials taken from Alexandria and older, unnamed sources. He described maps drawn when the seas were different, when the land was visible, when measurements were known. The evidence did not fit the timeline. Geologists state Antarctica had been ice-covered for at least 6,000 years. Accurate mapping would require advanced surveying, astronomical navigation, and a vantage point unaffected by ice. None of this should exist in prehistory. And yet the map insists. The response followed the pattern. Early studies were published, then reframed. Museum displays emphasize artistic value over cartographic precision. Requests for full spectral analysis of the ink and parchment were delayed. High-resolution scans were released selectively. One internal memorandum tied the map projection math to earlier anomalous datasets, explicitly referencing the copper-silver electrolyte notes. 1936 as part of a broader classification of non-conforming technical artifacts. The phrase appears once, then disappears. A naval cartographer working with the data noticed something else. The map's grid implies a prime meridian inconsistent with Greenwich, closer to one passing through the eastern Mediterranean. That choice is systematic. It suggests a lost geodetic standard. He submitted a paper proposing inheritance from an earlier global survey tradition. It was rejected. His security clearance review stalled. He retired early. He missed his wife's final surgery while waiting on administrative decisions that never resolved. Skeptics argue coincidence, that the alignment is forced, that coastlines are vague enough to match anything with enough imagination. One could argue that, but the numbers resist it. The map's errors are structured. Random sketches do not produce consistent angular accuracy across hemispheres. There is also the problem of compilation. The Piri-Reis map is not alone. Other early charts, Orontius Phineas, Mercator, show similar southern landmasses with comparable distortions. Independent sources. Shared precision. The same mistake repeated exactly is not a mistake. The implication is not that Piri-Reis knew Antarctica. It is that he inherited knowledge from someone who did. Someone with instruments. Someone with time. And that knowledge survived catastrophes, migrations, and burnings, only to surface briefly, then be dismissed. This is the fastest point of the pattern. Energy systems, material science, metrology, and now global surveying. The breadcrumb from 1936 is no longer isolated. It is connective tissue, an archival label for things that do not belong. The map does not ask to be believed. It asks why it was hidden. Latitude deviation calculated under 1 degree across southern coastline. Story 10. The measure without a measure Dequist Delta, Costa Rica. In the 1930s, banana plantation workers clearing jungle uncovered stone spheres. Perfect ones. Not symbolic. Not approximate. Near-perfect spheres carved from granodiorite, some over 2 meters in diameter, weighing up to 16 tons. They were not isolated. Hundreds existed, arranged in lines, clusters, and arcs. Then the bulldozers kept moving. Precision was treated as inconvenience. When archaeologists finally arrived, many spheres have been displaced, rolled aside, or destroyed for construction fill. A few were measured before removal. The results were quiet and troubling. Diameter variance across the best-preserved examples fell under 2 millimeters. Across massive stone, with no visible tool marks. Too round. Too uniform. Too repeatable. Granodiorite is hard and coarse-grained. It does not lend itself to symmetry. Hammering produces facets. Grinding leaves flats. Yet these spheres maintain continuous curvature. Not just visually, mathematically. Modern metrology confirmed curvature consistency beyond what manual shaping allows without templates, gauges, or rotational control. No lathes existed. No caliper survived. No records explain it. Early hypotheses proposed endless hand polishing over generations. That fails under time and error analysis. Human-guided abrasion accumulates deviation. These spheres converge, which implies feedback, measurement during shaping. A standard of roundness. A reference system now missing. The suppression here was physical. Plantation managers ordered spheres removed to speed clearing. Some were dynamited out of frustration. Others were rolled into ravines. Site maps vanished. Context was destroyed before documentation. By the time preservation orders arrived, the pattern was gone. One local surveyor attempted to reconstruct alignments from memory and surviving markers. He believed the spheres encoded geodetic relationships, possibly sightlines or distance units. His notes reference comparative standards, including a brief, unexplained mention of 1936 electrolyte classification, the same archival phrase tied to Baghdad and Delhi. His papers were never formally archived. He died before completing the survey. His daughter donated his notebooks. They remain uncatalogued. The official explanation is aesthetic. Status symbols. Elite art. That does not explain uniformity across distances, nor why some spheres were deliberately buried with only their apex exposed, as if marking coordinates. Nor does it explain why incomplete spheres are rarely found. Failed attempts should exist. They do not. There is a final anomaly. When researchers measured spacing between certain surviving spheres, ratios emerged. Not exact, but consistent. Multiples of a base unit no one can define. A measure without a measure. A system without its key. This is where the pattern resolves. Stone machined like metal. Energy stored chemically. Sound shaping matter. Gears predicting the sky. Heat restructuring walls. Concrete that heals. Stone flattened beyond tolerance. Iron that refuses decay. Maps that know the earth. And now, geometry without instruments. Each case alone invites dismissal. Together, they form a closed loop: materials, energy, measurement, prediction, an applied science stack. Fully functional. Then erased. The spheres were not the technology. They were the output. The proof that something else existed long enough to standardize perfection, and then was removed so completely that only the result survived. This is the hinge. Because once measurement is lost, replication ends. And when replication ends, history resets. Dimensional variance confirmed under 2 millimeters across multiple recovered spheres.